So here's number 10 from the worksheet. You'll notice that we only have one premise, so we're going to have to do a bunch of rearranging in that premise to get it to look like the conclusion. You'll notice a few other things. For example, we have X, Y, and Z here, same letters, but in this case, Y and not Z are combined in parentheses, whereas over here, the Z is out by itself as the antecedent of an if-then statement. Well, we do have a rule that allows us to go from or to if-then. It won't work in one step here, but that's implication. So we know we'll have to do that eventually, because what we have is or, what we need is if-then. What else do we notice here? One thing you have to keep in mind about the rules of replacement, that's 7.3 and 7.4, and that is that those rules, remember the double colon means it works both ways. If you have what's on the left, you can conclude what's on the right and vice versa. It also works with parts of statements. So we don't have to use the entire statement to apply a rule, as long as it's the rules of replacement. We can do it with just a part of it. And in this case, we have an and here. We can change that to an or, just by changing this part of the statement by using De Morgan's. So what we'll get when we do De Morgan's here is we'll keep this the same. All we're changing is the second half of the statement. And so this says, you don't have both Y and not Z. If you don't have both Y and not Z, then either you don't have Y or you do have Z. This says both of these aren't true. So all we know is that either this isn't true or this isn't true. So we changed both of those here. Y became not Y, not Z became Z, changed and to or, and dropped the negative there. On your proofs in Applia, Hurley might require you to use double negation. That is to call this not, and then in another step, take away the double negation. I'm going to skip that because I'm going to run out of room on this proof here in a second if I don't. So what did we say? We got that from line 1, De Morgan's. Line 3. A lot of different things we can do here. There is no one way to do a proof. As long as the steps you take are validated by the rules, then you can keep taking steps. I'm going to do it one way. You might come up with another way. That's fine as long as your steps are all legitimate. So my next step is just going to take these parentheses and rearrange them. This says X or not Y or Z. I'm going to say the same thing. X or not Y or Z. But I'm going to take these parentheses and move them here. And the rule that allows us to do that is called associativity. All right, so far so good. We're getting closer. One thing we have here, we have a bunch of ors, which is nice because we get a little disjunctive syllogism where we can rearrange things and switch them around. But in the end, we know we're going to have an if-then. So at some point, we're going to need a rule that allows us to change from an or statement to an if-then, and that rule is implication. Your second best friend after your new best friend, De Morgan's. When we do that, the way implication works is you change or to if-then, leave this alone. You leave the consequent, or in this case a disjunct, and now a consequent, and you negate the whole first part. And if you take a minute to look at your rule implication, you'll see that's how this works. The idea is this statement says you either have this chunk or you have Z. So what we say in a if-then statement is if you don't have that, then you have to have Z. That's all this says. If you don't have the stuff that happened here, then you must have Z. And that would be from line 3, implication. Material implication if you prefer. Hopefully we won't run out of room to finish off this proof. I may have to start writing a little bit smaller. Let's see. By the rule of transposition, which is essentially modus tollens. Remember, modus tollens says, given an if-then statement, if the consequence is false, the antecedent must be false. Well, transposition gives us a way to write that as a statement. So we have this if-then. What happens in transposition is you switch them, and you negate them both. So this says, if you don't have X or not Y, then you have Z. Another way of saying that is, if you don't have Z, then you can't have the other. Then this one must be false. So again, this is a case where Hurley would like you to put another tilde and then later come back in the next line and say double negation to get rid of the tilde, but I'm going to skip that step for the purposes of simplicity here. If you don't have the necessary condition, you don't have the sufficient condition. In this case, the sufficient condition is a negative, so we make it positive down here. And what rule did we say that was? Transposition. Line 4, transposition. And now we're almost done, really. Our conclusion, our conclusion is very much like our fifth line. We have the if not z, those are common. The only difference is that this says x or not y, and this says not both, not x and y. But they're the same thing, remember, because we have a rule, right, that allows us to go from an or statement to an and statement, and that rule is your first new best friend of Morgan's. Remember, the way De Morgan's works, this part of the sentence, forget this for now. This part of the sentence says x or not y. If you either have x or not y, you may not know what you have, but you know one thing. You don't have not x and y. That is, you don't have the opposite of this and the opposite of that. And that's how De Morgan's works. So we're done. There we go. There's our final line of our proof. It looks just like our conclusion. Perhaps not as much fun as you had hoped, but no, not too bad. 4 lines, yeah, it's pretty good. Takes some work. Like I said, there's a lot of different ways to do them. There's not only one right answer. I hope that you followed along and got this. And if you got it a different way, that's fine. The other thing to remember is, of course, I skipped a couple of double negation steps. You're not going to be able to do that in Applia, but you can see how it works. We would just have to add a double negation. I don't remember where. I guess here. When we moved along, I think in our first line we had a double negation we needed to use. That's fine. It's an additional step. Hurley makes it necessary, but from a logical perspective, we have not violated any rules.